Hello, and welcome to the Introduction to Philosophical Argumentation PowerPoint. I'm going to try this out instead of always posting YouTube videos that I've recorded. Sometimes I think it's easier for students to go back and forth between um, some slides that have recordings, and then you can learn by just looking at individual slides. So I hope this works and helps. All right, so philosophers use arguments in order to kind of do their work. That's the thing that philosophers generally focus on the most is different kinds of arguments for different kinds of positions. But you might ask what an argument is, right? What is an argument? What are these things that philosophers use? And of course, arguments in this context aren't the kinds of bickering that you might get into with your girlfriend or your parents or something like that. We have a more technical sense of argument, where an argument basically is a statement or set of statements that try to support usually the conclusion of the argument. Sometimes the conclusion itself is just the argument itself, but really what an argument in this context is it's a statement of a conclusion accompanied usually by some premises or some reasons for thinking that that statement is true. There's a general sort of standard form that arguments tend to come in, and in particular in this class we're going to be thinking through a couple of different kinds of very basic arguments. And generally these arguments kind of come in this form. You've got two premises and a conclusion. The premises, oftentimes one is sort of stated in support of the conclusion, and the other one is often stated sort of relating the initial premise and the second premise, and the conclusion, basically kind of combining them into a second premise. You'll see what that looks like in a moment. Now, there are different kinds of arguments that philosophers discuss and that people tend to use all over the place. One kind of argument, probably a kind that you're very familiar with, is an inductive argument. And inductive arguments tend to use things like statistics or probability or generalize from experience or from data. Inductive arguments are the kinds of arguments that are often used in science. And here's like an example of classic inductive argument. All swans that I've seen have been white. Premise two, I've seen a lot of swans. Premise three, therefore, it's all swans are probably white. Now you might think, okay, is this a good argument? Is this argument strong? Is it weak? And does the conclusion follow from the premises? Well, as it turns out, not all swans are white. But people used to think that all swans were white, sort of justifiably, because nobody had been to Australia. And in Australia, there happened to be some black swans, but a bunch of people in the UK and in parts of Western Europe for a long time were like, oh look, all these swans are white, so it must be the case that all swans are white. All the swans we've seen have been white, and so we are generalizing from a limited set of data to a larger generalization. It must be the case that all swans are white. Now, ultimately, that argument fails, right? It's a false argument. But is the argument good? Well, it depends, right? It depends on your sample size. It depends on how many things you've actually taken into consideration. If we just had premise one, like all swans that I've seen are white, but we didn't have premise two here, then the argument probably wouldn't be very good, right? Because you could have just seen one swan, and generalizing from one case, it's not a very good idea. But this argument is usually okay, depending on what you're thinking about. But sometimes, we're too narrow-sighted as individuals and humans to know when we haven't actually experienced enough in order to have a good generalization, in order to generalize inductively from data to a conclusion. Inductive arguments are sort of most often the kinds of arguments you find in science. And this is because in science, we're using experience and experimentation to more often than not, generalize from a set of data to what we might think of as a general claim about the world. The thing is that it's not always true when we make these generalizations, right? On the basis of the data that we have, the data might not actually represent reality. And so sometimes when we make a generalization, when we jump to a conclusion on the basis of an inductive inference in this kind of case, where we're thinking like, okay, I've got this data. This data seems to make it likely that this other thing is true, right? So like all the swans I've seen have been white, so it seems like it's probably true that all swans are white. It's possible, it's always possible in these cases, for the conclusion that all swans are white to be false, even given the truth of the premises, right? So it could be true that all of the swans that I've seen have been white, and that I've seen lots of swans, and yet the conclusion of the argument could still be false. Now, that makes the argument a little bit funny, right? Because if you want to, when you have arguments, you want your arguments to be airtight. You want them to be really strong. You don't want it to be the case that when you make an argument, you're giving reasons for a conclusion, but it's still possible for that conclusion to be false, even if your reasons are valid or good reasons, right? That would be a bummer, right, if that happened all the time. So philosophers are generally a little bit more interested in what we might think of as a kind of stronger argument than what we see in inductive arguments that are often put forward in science. Philosophers are looking, they tend to look for arguments that provide what we might think of as proof for their conclusions. And these kinds of arguments that are sort of, they stand alone and are very strong arguments, are often called deductive arguments. They're deductive rather than inductive arguments. They provide proof for their conclusions. Now, there are lots of different kinds of deductive arguments that are available in the sort of philosophical sphere, or what we tend to call logic. But here we're going to be focusing on two very specific kinds of arguments. We're going to be looking at, one main kind, and basically it's a kind of argument that involves the conditional. And so we're going to be looking at conditional arguments, in particular, two forms of conditional arguments, basically one's called modus ponens and one's called modus tollens. But in order for you to actually understand what these kinds of deductive arguments are or look like, you need to first know what a conditional is. So first, let's look at a couple of kinds of sentences. In the English language, and all other languages of the world, there are lots of different kinds of sentences, right? There's interrogative sentences, like where you ask a question, like what is that, or who is that, why is that? There are prescriptive sentences that tell you what you should or shouldn't do, what you ought to do, how you ought to be. There are imperative sentences. Imperative sentences tell you to do something very specific, right? They say things like shut the door, or close the window, don't speed on the freeway, right? Imperative sentences tell you to do or not to do something. And then we have the classic declarative sentences. Declaratives tend to state or try to state facts, right? So a true declarative sentence does state a fact, and a false one fails to state a fact. Deductive arguments, and the kinds of arguments that we're going to be discussing in philosophy, use declarative sentences, where declarative sentences are the kinds of sentences that are attempting to, state plain old facts. Now, declarative sentences tend to be able to be connected, especially simple declarative sentences most often, tend to be able to be connected by things that we call connectives, special kinds of connectives in our language. These connectives function in a particular way, and all of these connectives, you use them all the time, but in fact, these connectives are what we use in logic, and the logic of our language depends a lot on the connectives that are part of our language. The connectives, at least some of them here, I'll just sort of say, are words like and, or, the word not, or it's not the case that, which is a little bit tricky, but we won't talk about it yet. And the phrase if then, also the word neither, if then here being the important one. But for example, so here's an example of a connective that connects two declarative sentences, right? So take the sentence, the sky is blue and New York is east of California. Well, there we have two simple declarative sentences that are connected with the word and to create one complex connected sentence. Now, conditional sentences come in the form of if-then sentences, where basically what happens is where the sort of ellipsis is, the three little dots, we plug in different declarative sentences. So an example of a if-then declarative, an if-then connected sentence here would be something like this. If New York is east of California, then New York is east of Los Angeles. Conditional sentences sort of function to place a condition in the antecedent, or the first half of the sentence, the if part, on the consequent, or the second half, the then part of the sentence. And so, basically what this is what's going on here is that it's, if the second part is going to be true, then the first part has to be true as well, and that's kind of what the conditional statement says. It says if this, first part, then this second part. So if the first part holds, then the second part holds as well. So now take this sentence, if New York is east of California, then New York is east of Los Angeles. What exactly is it going to take for this kind of sentence to be true? Well, the condition of the sentence is that New York is east of California, right? So if New York is east of California, then the result, right? Then New York is east of Los Angeles. What exactly does the condition here require? Well, it requires that Los Angeles and California stand in a very special relationship, such that, if one of them is west of New York, then the other one must be west as well. And we know this is true because Los Angeles is in California, right? So because Los Angeles is in California, we know that, given that New York is east of California, then it's also going to be true that New York is east of Los Angeles. Conditional sentence, though, can sometimes be false. Take this new sentence. If Felix is a cat, then Felix is a mammal. What does it take for this to be true? Well, of course, a special relationship needs to hold between the nature of being a cat and the nature of being a mammal, which does, right? So if something is a cat, then of course it's got to be a mammal. But what about this sentence? If Felix is a mammal, then Felix is a cat. What exactly is being stated by this kind of sentence? As it turns out, this sentence is almost certainly false. But why is it false? The question comes down to how things could be such that the sentence doesn't actually turn out correct. How could that be? Well, it's not the case that the condition that being a mammal is a condition on being a cat. It's if something is a cat, then of course it must be a mammal. But the reverse doesn't happen, right? It's not the case that just because something is a mammal that it then must therefore be a cat. So supposing Felix is a mammal, it doesn't have to be the case that Felix is a cat. Felix might be any other kind of mammal, where this sentence basically seems to be suggesting that simply on the basis of being a mammal, the thing that we're talking about is required to also be a cat. The reverse is the case, but in this case, it's just not true. It's sometimes helpful to think about this using Venn diagrams. So we can suppose that Felix is a mammal, but not a cat, right? So we've got the mammal circle and the cat circle, and Felix is located within the mammal circle. The sentence, if Felix is a cat, or if Felix is a mammal, then Felix is a cat, is false here, because it is possible for Felix to be outside of the circle of cats while still inside of the circle of mammals. Ultimately, this is how we can come to understand when a conditional sentence can be false. Conditional sentences are false when it is possible for the antecedent or first part of the conditional sentence to be true while the consequent or the second part of the conditional sentence is false. Basically what this means is that conditional sentences are false when there's a disconnect between the first part of the sentence, the if part, holding true, and the then part of the sentence, the second part of the sentence, not holding true. If those two things can come apart in any way, then the sentence is false. Here are some examples of false conditional sentences that you might find in your everyday life. Suppose someone says, if Sally is at the party, she's drunk. Well, why might you think that is not true. Well, suppose Sally just got to the party, right? How could she possibly? I mean, supposing she hasn't been drinking at home, right when she gets to the party, she's definitely not drunk yet. Similarly, if the ground is wet, it must be raining. Well, why think that that has to be the case, right? The ground being wet, if it's raining, sure, the ground will be wet outside, but the ground being wet, somebody might have hosed it down, power washed it. You never know. If my car is not in the lot where I left it, it must be stolen. That can't be right. I mean, if the car was stolen, then it wouldn't be in the lot, but that doesn't mean that it might not have been towed. Here, each of these conditionals is false in the sense that it's possible for the first part, the if part, to be true, right? It's possible that, that my car is no longer in the lot where I left it, where the second part is false, right? It could be the case that, my car is not in the lot, but it hasn't been stolen. So this finally brings us to discussing certain kinds of arguments using conditional sentences. So this kind of argument is called modus ponens style of argument, and it goes like this. We have the classic sort of standard form here, two premises and a conclusion. And you can see that the first premise and the second premise kind of relate to one another, and then the second premise sort of relates to the conclusion in a particular way. The form of this argument is, we take a statement A, and then another statement, a conditional statement, if A, then B, and then finally the conclusion, therefore B, where you can plug kind of any sentences in for A and B here, as long as you're consistent throughout. So take this argument, premise 1, Sally is at the party. Premise 2, if Sally is at the party, then she's drunk. Conclusion, Sally is drunk. So is this argument really any good? Well, in a sense, yes, and in another sense, no. So it would be a good argument if the premises were true, but it's not a good argument if the premises are false. We can think of this argument as being problematic because premise 2 is just possibly false. Why? Because, if we suppose that Sally just arrived at the party, then 1 is going to be true, but 2 is going to be false. And so this argument could be sort of rejected on the basis of thinking, well, wait a minute, no, the argument's wrong because premise 2 is problematic. Premise 2 is likely false. Here's an example of a philosophical argument, one, in fact, that we'll probably discuss next week. A human person comes into existence at conception, premise 1. Premise 2, if a human person comes into existence at conception, then it is wrong to kill a human fetus. Conclusion, therefore, it is wrong to kill a human fetus. Is this a good argument? This is the kind of argument that is often trotted out against the moral permissibility of abortion. Well, as it turns out, this kind of argument is what we would call a valid argument. A valid argument has a particular kind of structure, and but what we can ask further is whether or not this argument is sound. And those are both different ways an argument can be good. An argument can be good because it's valid, that is, that it has the right kind of structure, it's shaped in the right kind of way. But it can also, a good argument needs to be, a really good argument needs to be sound. Being sound is the best way an argument can be. So what is it for an argument to be valid and for an argument to be sound? Well, an argument that is valid is such that the premises, if true, guarantee that the conclusion is true. But it's always possible that, the premises aren't true. The idea here is just that the argument is set up in such a way that if we suppose that the premises are true, we suppose that it is true that human people come into existence at conception, and that it's therefore wrong to kill a human fetus. Well, if we suppose that premise 1 and premise 2 are true here, then the conclusion simply follows. But that's just a supposition. We've just supposed that the premises are true. We don't know whether or not they're true. They could be false. An argument is sound when it's both valid, that is, the premises guarantee that the conclusion is true, if they're true, and the premises are true. So a sound argument, a sound deductive argument, the best kind of philosophical argument that's out there, is one where the premises are true and the premises guarantee the truth of the conclusion. So it's not possible in any world, in this case, for the sound argument, for the conclusion to somehow turn out false, given that the premises are true. A second kind of philosophical argument that we're going to be looking at in this class is called a modus tollens argument. Modus tollens arguments work very similarly to modus ponens type arguments, but they include what we might think of as a negation, a not feature, and basically they go the other direction when it comes to thinking about the conditional. So the argument form of a modus tollens argument works like this. Again, we're using A and B for just any arbitrary sentence that you want to put in there. If A, then B, premise 1, not B, premise 2, therefore not A. Remember, modus ponens goes the other way. It says if A, then B, A, therefore B, whereas modus tollens says if A, then B, not B, therefore not A. This argument form also relies on the conditional, but here instead of affirming the antecedent, the first part, like we did in modus ponens, the argument denies the consequent, denies the second part, and so concludes with the denial of the first part. Here's an example of a modus tollens style argument. If Felix is a cat, then Felix is a mammal. Felix is not a mammal, therefore Felix is not a cat. Supposing here that, the premises are true, if Felix is a cat, then Felix is a mammal. That's got to be true because the collection of cats in the world are all mammals. We know that, in order for something to be a cat, it must be a mammal. But if we also take premise 2 to be true, that Felix is not a mammal, then it couldn't be that Felix is a cat, right? Supposing Felix is a turtle, then he's not going to end up being among the cats or the mammals. What you need to know and sort of take away from this short little introduction to philosophical argumentation is that when an argument is of the modus ponens or modus tollens form, it is a valid argument. That is such that if the premises are true, then the conclusion must follow. What that means, and when it comes to thinking about valid arguments, is that if we dislike the conclusion of a valid argument, and we want to argue against that conclusion, what we have to do is we have to pick one of the premises of the argument to deny, to say that we think it's false. In order to do that, you have to come up with a good reason for thinking that one of these premises are false. But you can usually do that. There are different kinds of reasons that are good for, arguing for and against particular premises, but conditional premises are the kinds of premises that are a little bit more complicated to try and deny. And so I just want to point out here that the way in which you deny a conditional premise, like that is a conditional statement, is you try to figure out how that conditional premise or statement could be false. And the way you think about how it could be false is you try to understand how it would be possible for the antecedent, the first part, the if part of the sentence, to be true, while the second part, the then part of the sentence, the consequent, is false. If you can come up with a situation or scenario in which it's possible for the first part to be true and the second part to be false, then you can show that the conditional sentence itself doesn't always hold and so is therefore false. In philosophy, we tend to use valid deductive arguments most of the time to argue about different kinds of topics, and we argue about whether or not these kinds of arguments are sound or not sound. Generally, we sort of focus ourselves to valid arguments. We only use these valid arguments because they're sort of more useful for actually doing philosophical work, and then we try to argue for or against these arguments by saying whether or not the premises are true or not. And then most of the philosophical work is put in defending a premise or arguing against a particular premise of a valid deductive argument. All right, I hope you enjoyed that, and I'll make another one of these sometime soon.